session. And all right, so I am gonna start. All right, let's start. I'm not gonna wait any longer, so whoever, probably people will come in between. All right, welcome. Again, thank you very much for taking your time and being here. So I know many of the parents, you are actually many of the parents of strong students, or let's say interested students in taking physics courses. That's why you guys are here. And okay, I believe that's stop there. My name is Armin Hodaei. I'm one of the lead examiners for IPhO 2026, which is going to be in Colombia next month. At the same time, I'm also Team Canada coach for International Astronomy and Astrophysics Olympiads. And I'm also the founder of PhysOlymp Academy, which I mean, I've been around. I mean, this academy's been around for the last year-ish, I'd say. It's more than a year, of course, but officially I started working like under this name last year. So my work sits at an intersection of teaching, research, and elite competition preparation. That's basically how what I do in daily basis. I teach physics. I do astrophysics research. I'm a PhD student right now, and at the same time, I train students for kind of problem solving at regular day school as well. Tonight is not just I'm not going to do a physics lecture, of course. I'm not here to derive equations, of course. I'm just the goal here is clear, and I want to show why competition physics and astronomy matter, and how they're different from AP courses or like daily credit courses that schools offer for physics. What is F equal to MA, and what is USAPhO, and what is USAAAO pathway? So I'm going to explain what these competitions are one by one. All right. So let me go through the first slide. All right. Okay. So tonight's going to have 4 parts. As you can see, first I'll explain who I am, a little bit of background, which I kind of talked about, but I'm going to quickly go through. Second, I'll talk about why Olympiad physics matters, and especially for students who already have strong grades, strong AP courses, strong AP scores, and strong math background. Third, I'll explain how the main competition pathways we're focusing on at our academy. So F equal to MA, USAPhO, and also USAAO, which is the Astronomy and Astrophysics Olympiads. Fourth, I'll explain the summer courses that we have here at the Academy. So by the end, I want you to be able to kind of have a pretty good practical answer to this question. What is the right next step for my child? That's my goal. All right, so I'll start with who I am. So my background connects 4 roles that students often experience separately. First, I'm a science and physics teacher. I work with students in the classroom, so I understand the students and what students are actually learning in school, and what is missing in between, and what's the connection between those and students who are taking AP courses, and for the students who are actually doing Olympiads. Second, I'm an astrophysics researcher. Right now I'm doing my PhD work at York University, and my research focuses on observational astrophysics, quasars, and high velocity outflows. That research background, of course, it matters because it's like astronomy and physics is basically what I'm doing in a daily basis, and at the same time I'm doing lots of competition work, problem design, tutorial design, and also coaching the team. And it's not just about like memorizing facts. They're all about modeling real physical systems, interpreting data, and reasoning from the evidence. That's basically what Olympiads is about. Third, I'm an Olympiad coach. I've worked with Team Canada for the past 6 years. I've been training the team and taking the team to the Olympiads. I've trained students for national and international competition environments. That gives me a very clear view of what separates strong candidates and strong classroom students from a competition-ready student. And fourth, and the last one, I founded this academy because I saw that gap in between, you know, many students are ambitious, but they do not have a clear idea. They don't have a structured way to move from, let's say, school physics into like serious Olympiad level problem solving. At my academy, I kind of want to do that, and that's why the training that we're doing is basically based on that. So my job tonight is to kind of translate this elite STEM training into a clear family decision for you guys. So now let me explain why that background matters for your child. Cool. So most courses prepare students for a topic. They teach like mechanics, electricity, waves, astronomy, blah, 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 blah. But competition prepares, competition preparation is totally different. It prepares students for a specific standard. So I see the full path. I see what students learn in the classroom. I see what national contests such as F=MA, USAPhO, and Canadian Astronomy Olympiads or USA Astronomy Olympiads require. I also see what the international stage expects, because I'm both in the front and back end of those international Olympiads, IOAA and IPhO. At every level, the same core of skills appear, and that is, can student build a physical model and defend the reasoning, and can they solve problems under pressure or under like time pressure that they have. Of course, I have many brilliant students, which unfortunately, when it comes to pressure or putting them under like, you know, a specific, if you give them some specific time, okay, you have to finish 5 problems in like 2 hours, they get stressed, and they usually are not able to do much, unfortunately, because of that. This is the difference between knowing a formula and thinking physically. A formula may get a student through a familiar school problem. However, in a competition, student has to decide which physical principles actually apply before they can even start calculating anything. That is why training is not just more homework. It's a different type of, let's say, intellectual preparation. All right. And this connects directly to the admissions as well. Admissions reality to the top STEM students. So top STEM universities are not short of excellent, let's say, applicants or excellent students. They see many high GPUs, especially these days with the great inflations, which happens everywhere in North America. They see many students with high AP marks, like 5s at AP or high GPAs. These achievements, they do matter. So I'm not saying grades and APs important. Of course, they're all important. Sorry. Yeah, they're all important, but the thing is, the question is what makes the student rare. The strongest differentiator is demonstrated excellence at something difficult, rare, and independently validated. So not something the students simply say they enjoy, not something that every applicant has, something that shows the student can perform outside the normal school structure. And that's where Olympiads come in. So Olympiad physics and astronomy can provide that kind of signal. A strong result in any of these competitions or a similar pathway tells a clear story that the student can reason deeply, they can solve unfamiliar problems, and they can handle rigorous external standards. And I want to be clear, no competition guarantees admission. So some people think like, okay, if I got into this competition, everything is guaranteed. I'm going to get into MIT, my dream school. Of course, it's not a guarantee, but it's a very, very good addition to everything that I just mentioned. It can give academic credibility, and that's what I'm trying to say. But of course, there's a trap that many strong students and parents fall into. So often parents are wondering, okay, my child has a 99 percentile in AP Physics. Why they couldn't do any Olympiad stuff? And they're kind of confused about this. So the answer. The answer basically is what I call the AP trap. School physics and AP physics are valuable, of course. They build vocabulary, formulas, concepts, and standard procedures. But many students learn a pattern, like recognizing the topic, choose the right formula, substitute values, and finish a familiar problem. That's basically what happens in almost all physics courses or AP style questions. However, Olympiad physics or astronomy Olympiad, they reward a different instinct. The student must read the physical situation, decide what is conserved, identify the constraints, build the model, and often derive before calculating. Some problems are all derivations. They don't even put in numbers. They're all like 3D models. They need to sketch, they need to understand, and then they can solve the problem. In AP Physics, students often ask, which formula do I use? In Olympiad Physics, the better question is, what is the system doing? What is the system doing physically? Competition physics punishes formula hunting. It rewards physical intuition, speed, and clean reasoning. So if only you identify, okay, this physics Olympiad problem is about this and this and that topic, and if you just put the formulas in, you're going to get 0. So no one cares if you knew a bunch of equations or formulas in physics Olympiads. It's important to know how to use those and solve the problem or come up with a system. All right, so now the question is, what exactly do these exams test? Okay, so there are 3, I'm gonna call it muscles that matters. First is model building. So can the student take a messy physical setup and turn it into a solvable model? This means choosing a system, identifying forces, recognizing what can be ignored, and translating the situation into physics. The second problem is decomposition. Problem decomposition. Can the student break one difficult problem into smaller physical claims? Elite problem solvers do not usually solve a hard problem in just one jump. It's impossible. They divide it into little teeny tiny steps, and then each step is basically a different thing, and they start solving those, and then they connect the dots and they see the whole picture. And third is speed under pressure. Unfortunately, this is a part of the process of Olympiads. Of course, speed is very important, and speed under pressure. So F equal to MA, for example, is not only difficult, it is fast. So maybe if you give a good, strong student like 4 hours to do it, they might be able to solve most of the problems. But when you give that short time constraint, then it makes it really difficult. So basically, students have to reason accurately when every minute basically matters. These skills are trainable, but they're not built by reading solutions 1 week before the exam. So it needs some time. They're built by repetition, feedback, correction, and of course timed practice. So This is exactly why our summer training matters here. So summer gives students the time to kind of go through not I call it building habits. It's important for that specifically. So now let me map the two main pathways here. Okay. So there are two high leverage pathways we're focusing on. The first is the physics pathway, so F equal to MA, then USAPhO, and eventually IPhO track for the very top students. F equal to MA is typically the January mechanics qualifier. It is the entry point for the US physics Olympiad pathway. A strong F equal to MA result places the student in a nationally visible pool of physics talent for students interested in physics, engineering, computer science, or even quantitative STEM fields. This can be a powerful academic signal. The second pathway is USAAO, the US Astronomy and Astrophysics Olympiad. So that's basically the acronym. This is one of the most underused opportunities for strong math and physics students. So there's a big drop in the student body when they apply for astronomy Olympiads, which is a very good opportunity many people are missing. Many families know about the math contest, AP courses. Some know about AP equal to MA, but far fewer know about astronomy Olympiad, which actually makes it okay, I call it easier to get in because, you know, less competition. But again, at the competition level, astronomy is not just, you know, telescope facts or like finding stars in the sky. It is mostly physics, so pure physics. And that's why most of my students who do well in astronomy Olympiads are the ones who are really good with physics as well. So they need gravity, they need to know orbits, they need to know light, they need to know spectra. Temperature, thermodynamics, luminosity, data interpretation, and mathematical modeling. So to be honest, I think that astronomy Olympiad is basically a better let's say way of I mean, it's a better competition compared to physics Olympiads to basically measure student understanding and student let's say competencies. For students who like space, physics, coding, data, astrophysics, of course, the second pathway is better to basically follow. And it's, as I mentioned, it's rare, rigorous, and much more memorable than the physics one. The important point is this: students do not need to take every route. They need the route that best fits their profile. So they need to be thinking, okay, which one I like more, I want to get involved. But next question is timing. Timing is important, of course. So our cohort is beginning in summer, in July 1st and 2nd. The school year begins in September. Again, it depends where you live, but usually start around that time. F equal to MA is in January. USAAO, which is the Astronomy Olympiads, is in the winter cycle as well. A student who starts in July gets 8 focused weeks before the chaos of school returns. And they can build mechanics fluency, practice competition style thinking. They can make mistakes. Still got a lot of time, and they get feedback through our courses, and they develop speed as well. A student who waits until September is not really starting with 4 or 5 calm months. They're starting with homeworks, tests, clubs, and much less flexible time. That's why I believe like these summer courses are important. Olympiad skill compounds and all of those stuff. So this is why I do not treat summer as extra time for serious preparation. Summer is actually the preparation window. It's very important. So if a student is only casually exploring physics, they can start whenever they want. But if the goal is like serious and they want results in January or February, July is the right time to like start to basically build that foundation. So now let me explain which course fits which student. So these are the courses that basically we have. This is the most practical part of the webinar, I'd say. The goal is not to overload students, of course. So I designed these courses in a way that one student can take all of them at the same time, but of course, I'm kidding. I'm not gonna ask any student to take everything together, especially the AP courses. The AP Physics 1 is best for students who are actually taking it next year, especially students with no prior formal physics knowledge. This course is about building a strong foundation before the student develops any bad habits or loses confidence. AP Physics C, I'm only offering the mechanics one in summer, is best for students with calculus knowledge because it requires calculus. This is a strong fit for students interested in engineering, physics, or any quantitative field. Epical to MA, which is basically USAAO prep, is best for strong algebra and trigonometry students who want to prepare for the January Epical to MA exam. Of course, that one also needs calculus. This one's more competition focused. It is for students who are ready to train seriously with unfamiliar mechanics problems. So if they're kind of good with physics, that's basically what they should be taking. USAAO prep, that is the astronomy Olympiad thing. It's about astrophysics, space, data analysis. It is a strong option for students who are good at physics and math, but want more, let's say, distinctive pathway that most families already know. A simple rule of thumb is this: AP Physics builds, AP courses basically build the foundation. Epical to MA and USAAO turn that foundation into competition grade credential. And now let me explain what makes. Oh, okay. Sorry, my image is like cut off. Anyways, all right. Cool. So PhysOlymp Academy, what we have is not a passive video course. It's all going to be live reasoning, correction, and rigorous feedback. Actually, I believe the most important part of our course is me personally giving feedback to the students. So every week they're going to have like homework, and homework's going to be graded and given back to the students with useful feedback for them. The student can watch a solution and feel like they understand it, but that does not mean they could have produced that solution under exam pressure. In a live class, I can see where the student's reasoning breaks. Did they choose the wrong system? Did they apply conservation incorrectly? Did they ignore a constraint? So many things which I'll be observing. Did they jump into calculation before like building the model? So again, those 3 pillars that I talk about, it's very important, and that's basically what I try to teach my students to build before diving into problems. So diving into solving a problem. Also, the small cohort format matters because I want to be able to like reach out to everyone. We are going to have a Discord channel for every course, and of course we can have like interaction there with the students. That's why again that 20 it's like the cap. All right. What else? Yeah, so there are also going to be mock exams, timed practice, which is going to be for all of our courses. Doesn't matter which courses that we have, all of them would have that one. Cool. And so for this summer, we have like 4 different ones, which I talked about. So Epical to MA, the timings and everything is written there. They're going to have 15 sessions. recordings are going to be there, problem sets, and timed mock exam for all of the courses we're going to have. One note which I wrote down there is that I am going to go to IPhO in first week of July, so that's when I'm not going to be there, but students are going to have pre-recorded sessions on the day of when I'm actually not there. So the curriculum is not going to pause, going to continue, and students will see the full course sequence as well. All right, so now the very last thing I want to, so let me kind of talk about, hopefully this should make your decision making easier. If your student has no prior formal physics let's say training, and is taking AP Physics 1 next year, definitely go with AP Physics 1. If your student has strong mechanics and wants a competition challenge, then go with EPICO2MA. If your student is taking calculus and wants AP Physics C, again, choose AP Physics C Mechanics. If student like space, astronomy, astrophysics, then choose USAAAO, which is again the first round prep for Astronomy Olympiad. If you're not sure, do not guess. Just send out an email to me, or again, I have some book-a-free 15-minute placement calls. You can always do that, or you can just send out an email. We can come up with a time, and in that call, I can give you some key information, and I'll ask about the background of the student, physics background, math background, and what grade they are, and then I can help you out with like choosing which course is going to be better for the student to take. So something for you to think over the weekend. The question is, the question is not, is my child Olympiad ready right now? The question should be that, I mean, most students are not ready. Even the ones which they are training hard to get into an Olympiad team this year, of course, they don't feel ready. And that is the point of this training. The better question is, what kind of STEM applicant do we want this student to become by January next year? Do we want them to be another strong student with good grades and AP scores? This is valuable, but unfortunately, it is common nowadays. Everyone has those. Or do we want them to become kind of students who can reason independently, solve unfamiliar problems, and show rare evidence of scientific excellence? If the second one, if the second answer is closer to your goal, then summer is the window you need to register. So you can register or book a placement call at my website, or again, if you're unsure, please do not hesitate to contact me. I usually reply within a day or even faster than that. So please do not hesitate to reach out. I believe I do have the 15-minute calls also somewhere in my website. I believe it was somewhere that you can like book a consultation call. If you couldn't do it, just send out an email, and basically I can get it. All right. Thank you very much. This is everything I wanted to go through. Give me 1 sec. I will stop